Hi Math 9s, I wanted to take a few minutes here just to go through a couple example problems or a couple of our practice problems from our tangents. So I'm going to go through not every single one, but I'll try to hit a couple different types of questions, go through, explain my reasoning, show my work, so hopefully that helps you while you're doing your problems. So let's start off here with number 3. It says in each diagram, point O is the center of each circle. So you'll notice a trend where there's a point at the center labeled O, usually we call it. They want to know which lines are tangents. So this is basically just, do you understand what a tangent line is? So I see a couple different lines. I see line MN, which is a diameter. I see line OP, which is a radius. And then I see line QR. Now, out of these 3 lines, the only one that makes the criteria of being a tangent is line QR. So the right answer here would be QR. Remember, a tangent line touches the circle at just one point. In this case, it's point P here. For number 4, it says point Q is a point of tangency. So there's our point of tangency. That just means that this line here is a tangent line. Point O is the center of each circle. That's there. What is each value of D degrees? So it's just asking, what is this angle right here? And well, I guess I just drew in the answer. But remember, when we have a radius, this line I'm highlighting in green, and it meets with our point of tangency, we get a 90-degree angle. So it seems like it might just be a trick question, seems too easy, but really in both of these examples, they are 90 degrees. Oops. Let's look here at number 5. Point P is a point of tangency, so there's our tangent, which means that line PQ is a tangent line. O is the center, okay. Determine each value of x. Well, we have our radius meeting up with our point of tangency. We know that x is 90 degrees. It's a right angle. In B, let's take a look here. Well, B, here's my point of tangency. Here's my tangent line. Here's my radius. So that means that right here we have our 90-degree angle. But we're trying to find this angle here. So remember, the angles inside a triangle add up to 180 degrees. So if I subtract my 90 and my 23, gives me 90, and then 90 minus 23 gives me 67. I end up with 67 degrees. I'm just going to double check my answer key, make sure my mental math is right. Yeah, we end up with x equaling 67 degrees. So that means if I add 67 and 90 and 23, I get 180 in total. Whoa! Things are happening right now. All right, there we go. So let's look at number 6 now. Point P is a point of tangency, just like the other ones. O is the center. Okay. Determine each value of A. So for question A here, we're trying to find this missing side. So the way we find missing sides is with Pythagorean theorem. So remember, we have to make sure we know where our 90-degree angle is, which means that our missing side is going to be hypotenuse. So I'm actually going to label it C to use my Pythagorean theorem. And then I'm going to label A and B. And then remember, C squared equals A squared plus B squared. So C is going to be the square root of A squared plus B squared. So it's going to be the square root of 3 squared plus 4 squared. I'm going to plug that into my calculator really quickly. You can do that too. 3 squared plus 4 squared, square rooted. That means that C is 5. So each value of A, if I go back to the original problem, we've called it A. So I'm going to answer it by saying A is equal to 5. And so for B and C, you would also use Pythagorean theorem, just being careful with where your right angles are. Number 7, point T is point of tangency, okay. O is the center. Determine each value of D degrees and E degrees. So we're trying to find two missing angles, and I see them there. Okay, well, if T is a point of tangency, that means that I have a 90-degree angle there and a 90-degree angle there. And then I can just look at my two triangles separately. So I'm going to start over here with this triangle that I'm highlighting in red. I know this angle is 28. This angle here is 90. To find my missing missing angle here, I would just go 180 minus 28 minus 90. Gives me 62 degrees. So D would be 62 degrees. And then I can do the same thing over here for E. So I would go 180 minus this 90-degree angle here minus the 35-degree angle here. And I would get E equal to 55 degrees. Please be really careful. A lot of people like to look at these and say, well, they look like they're similar, so maybe they're the same. Or maybe they're the same as these for some reason. No. The angles inside a triangle, the interior angles in a triangle, add to 180. So use that property to help you figure out the angle. And B would be the exact same thing. So just make sure you know where that right angle is. It would be there. You can use that property to help you figure out the missing angle. 8A is not too complicated. S is a point of tangency, so there's my point of tangency. O is the center. So the first thing I'm going to do is draw in my right angle, determine the value of A. So I'm trying to find this missing side. Well, I have a right triangle, I have a missing side. Use Pythagorean theorem to find your hypotenuse. I'm going to leave that for you guys. You can do the math there. Same thing with B. Your right angle is there. Use Pythagorean theorem. 9 is the exact same thing, but now they have two triangles drawn onto the same circle. It is literally the exact same as these two problems up here. We just joined those triangles together. Do you guys notice that? It's pretty much the exact same thing. So to find A, you need to use this blue triangle that I've outlined really wobbly. And then to find B, you need to use the green triangle that I've outlined. And just use Pythagorean theorem. Number 12 here is almost identical to a question that we did in the notes, so I'm not going to take my time to go through that right now. You can look back into the notes and use that example. 13 is also really, really similar to that question. The only thing that you might need to do is figure out how to turn this shape into a triangle. Here's a hint. You should be able to figure out the rest there. Number 14 gets a little bit more difficult. So you're trying to find the values of x, y, and z, which are all, oh, nope, not all missing angles. Z is a missing angle, x and y are missing sides. So let's start with x. So if I'm trying to find x, which is this side length here, I would need to use this triangle with my 90 degrees. So I would label my hypotenuse, I'd label side A, side B, and then use Pythagorean theorem to find side x. To find side y, I would also use Pythagorean theorem, so I'm trying to find that missing side. I know this length here is 12, this length here is 6, there's my 90-degree angle. Use Pythagorean theorem to find, this could be A or B, I guess. There's your hypotenuse. To find side z, the same thing we were doing before. I know this is 90 degrees. I know this is 30 degrees. So all I would have to do is go 180 minus 90 minus 30, which leaves me with 60 degrees. Number 17 is a little bit trickier, so I'm going to take some more time to go through this. So a circular mirror with radius 20 centimeters hangs by a wire from a hook. So here's the mirror. They've shown us the radius, 20 centimeters, good. The wire is 30 centimeters long, so it's been bent in half, so 15 and 15 makes 30. There's a hook in the middle, and is a tangent to the mirror in 2 places. So we would need to go through and figure out where it is tangent to the mirror. Well, I see right here that looks like it would be a tangent line, so I'm going to say there's a 90-degree angle there. There's also a 90-degree angle over there. How far above the top of the mirror is the hook? So here's my hook. I want to find out from the top of the mirror to the hook, that missing distance there. So that is what I'm looking for. I'm going to call that X maybe. Okay, this is a little overwhelming. We might try to draw in, and this is what a lot of grade 9s will do. I'm going to erase this just to clear out some space. A lot of grade 9s will like try to draw a triangle here and like try to do this, but we don't know what this length is. We don't know what this is, so that doesn't really help. Let's do what we've been doing this whole time. So I'm just going to look at this side. There's 15. There's 20. Here is a missing side. And there's my right angle. I can use Pythagorean theorem to find this missing length here in red. And then if I know that whole length, I can subtract this length here, which I know is the same as a radius, to get this little bit at the top. So first things first, let's find this whole missing side here. So this is going to be my hypotenuse, so I need to go C equals the square root of a squared plus b squared. So C is going to be the square root of 20 squared plus 15 squared. So that missing side, let me just punch this into my calculator. This ends up being 25 centimeters. So I know that this whole missing side here is 25 centimeters. But I don't want to know what that whole side is. I just want to know what here to here is. Well, I know that from this blue line to this blue line is a radius, which is equal to this radius over here. So if the blue part is 20, I can go 25 minus 20 to get 5 centimeters left over up here. So to answer the question, how far above the top of the mirror is the hook? It is 5 centimeters above the top of the mirror. How do you know? Well, we just did math to show that. You don't need to answer that in a sentence. So it's a little bit trickier, but not too bad once you understand how to use your Pythagorean theorem. This last one here is a little bit trickier. I'd say this is the hardest one in the whole assignment or in the whole practice. I'm not going to go through this one because I want you guys to give it well, maybe I will. Yeah, let's do it. So 2 cylindrical rods are bound with a strap. Each rod has a diameter of 12 centimeters. So they drew those in. 12 centimeters, and then this red is the strap that's around it. How long is the strap? So how long is this red strap, whatever it would be made out of? Give the answer to the nearest tenth. And then they give us a formula for the circumference of a circle. Remember, circumference is the distance around the circle. So we're probably going to have to use that information. So let's look at that first. So if I'm looking at this distance here that I'm outlining in red, that is 1/2 of the circumference of those circles. If I look over here, that's another half. So altogether, between both of these ends, I have the distance of 1 full circumference. So to find that red part, I'm going to use my circumference formula. So circumference equals pi times the diameter. I'm going to use the pi button. use the pi button on your calculator. Don't use 3.14. And I'm going to multiply it by 12. So let me just find my pi button. There it is. So I'm going to go pi times 12 to give me 37.699. And it's good to not round until the very end. So in high school, you'll be expected to leave your answer unrounded until your very final answer. So don't round this number yet. All right, so I found the length or the distance around this red section, but now I have, I'm going to just color them blue, these blue lengths to figure out. Well, if I look, I'm going to do this in green, from the center of the circle to this edge is a radius. And a radius is half of the diameter. So in this case, that radius is 6. And look, it's equal to that distance there. So that would be 6. This distance here would also be 6. Same thing here and here. So I end up with 6, 12, 18, 24. My total blue length being 24. So now I need to add 37.669 to 24. I get a final answer of 61.699. Rounded to the nearest tenth gives me 61.7 centimeters. And don't forget units when we're writing out answers like this. Here's our answer key. So as you're working through, you can double check your answers. If you have any questions, please shoot me an email. Let me know. I'm really, really happy to help you guys out with that. Thanks.